In this video, we are going to study about a standard normal distribution. So many statistical procedures can be carried out using a normal curve. And the normal curve is the curve that has a bell shape and it is symmetric. So any population that is represented by a normal distribution curve is considered to be normally distributed. There's a few important characteristics of the normal curve. So a probability density function, or the PDF, is an equation that we use to compute the probabilities of a continuous random variables, and the total area under the density curve is 1, and because the total area is also 1, there is a correspondence between the area and the probabilities. Now we know that the mean of the curve is at the center, and the mean in this case is also the median and the mode of the distribution. Alright, let's take a quick look at the two different curves here. Now remember, the standard deviation measures how the data spreads out all over the entire distribution or the population. If we have a larger standard deviation, the larger value of sigma, then your data is more spread out all over the places, or it should have the curve like the red one here. And if your standard deviation sigma is small, then your data stays together, or you should have a more tall and narrow like the black one right here. So the red one has a higher standard deviation, and the black one has a smaller standard deviation sigma. Now, most of the time we are more likely to use the standard normal distribution, because this is easy to use, and there's a table for the z-score on the appendix of most of the textbook that you can refer to. So let's talk about what is the standard normal distribution. The standard normal distribution is when we set the mean to be 0 and the standard deviation is equal to 1. So we refer to that as a standard normal distribution. Again, the mean is at the center where it is equal to 0, and the standard deviation is equal to 1. Alright, so let's quickly refer to this figure here. We have a standard normal distribution curve where the mean is equal to 0, so anything before the 0 or on the left side of 0 is considered to be the z-score of a negative z-score, and anything after or before the 0 is considered to have the positive z-score. And the centers right here is when your z-score is equal to 0, and then the area under the curve is just the proportion of a population that is less than or equal to that specific z's value right here. And we can also say that the probability that a randomly selected individual from the population will have the characteristic that's right by the interval of the value inside that area. Okay, we talk about the z-score, so now let's define what is the z-score for the standard normal distribution. The z-score is telling you how many standard deviations that a value is from the population mean. And we can compute a z-score using the formula here. The z-score is equal to the value of your data x, subtract the mean of the population divided by the standard deviation of that population. And recall that we study about the empirical rule from the earlier chapters, and for the empirical rule we have this normal distribution. where the mean is also in the center here. So the empirical rule is saying that there are 68% of the population will lie between the -1 standard deviation and +1 standard deviation above the mean, or within 1 standard deviation above the mean, you can find 68% of the population. And if you increase to another standard deviation to the mean plus 2 standard deviation, or the mean subtract 2 standard deviation, then within 2 standard deviation about the mean, there are 95% of the population will lie inside the 2 standard deviation below and above the mean. And then for 3 standard deviation above the mean and 3 standard deviation minus below the mean, we can find almost everything, or 99.7% of all the population will lie inside this 3 standard deviation above and below the mean. So sigma again is the standard deviation, the mu value is the mean, so I plus sigma, that means I move 1 standard deviation above the mean. I subtract 1 sigma, that means I move 1 standard deviation below the mean, and this is minus 1 standard deviation, this is plus 1 standard deviation, and therefore that interval right here is 1 standard deviation above and below the mean. There are 68% of the population will lie inside that interval. Let's take a quick example. Here we are looking to find the area between the z-score of -1.45 and then the z-score of 0.42. So we know that at the center right here, your z-score should be 0. So 0.42 is above the 0 for the positive z-score, and negative 1.45 is the z-score for the negative area. Negative portion. Now, how do I find the area between -1.45 and plus 0.42? Now, there's a few ways to do that, but let's try to take a look at how do we do that using the z-score table. So if we use the z-score table, let's take a look at the 0.42. So 0.42, if I use the z-score table, this is the 0.42, so that is bigger than 0, or that should be the positive z-score. So I go ahead and I use the positive z-score. Now remember that the z-score table here only gives you the cumulative area from the left side of that z-score. We are looking for 0.42. So if you go to the positive z-score, so 0.42, what is that value? This is 0.4. It's right here. Now we need another 0.02 to get 0.42. So that should be this value right here. Okay, because this is 0.02 plus 0.4 give me 0.42. So the number inside the body here give you the area to the left of that z-score. So we get 0.6628. And then we do the same thing for negative 1.45, and this is negative z-score, so we have to use the negative table. So negative 1.45, so minus 1.4 is right here, so we need to look for another 0.05. 0.05 this column, so we go all the way down to negative 1.4. That should be 0.0735. Okay, and then because we are not looking for the area to the left side of 0.42, and we are not looking for the area below minus 1.45, we are looking for the area in between the two values. So all we do now is we take this area, this is the whole area below 0.42, we subtract the portion after minus 1.45, so that's why we can get the one in the middle. So just take the two values and then subtract each other, and then we'll get 0.5893 as the area between the two negative and positive z-score here. Now we can also use the TI-84 calculator to help you to find the area between these two values. Let's take a quick look at that. So what we do now is we go to second vars to get you the distribution. Because this is the normal distribution curve, what we do now is we use the normal CDF. CDF stands for the cumulative distribution function. So this is the area all the way from the previous value up to the current value. So now we have the lower is minus 1.45, minus 1.45. The upper one is 0.42. And make sure that because this is a standard normal distribution, we are using the lower and the upper as the z-scores. Therefore, the mean should be 0 and the standard deviation should be 1 for the standard normal distribution. And if you paste that into the formula, the function, then we should get the same and similar value, which is right here. Let's confirm the answer, 0.5893, which when we route to 4 decimal places.